On the question where we pulled the north magnet out of the solenoid.
Yeah. Okay. So let's talk about this. So this is actually this is the one that we did. I had the solenoid, I had the magnet on the end of the bar, and we moved that in and out. Okay, this is actual data from there. Okay. So on this one, so determine the induced current when the magnet is being pulled out. Okay. So here's the first diagram that you have to realize is that here is the magnet, okay, and this is the north end. So the magnetic field is going out in that direction. So here's the front edge, the circular edge of the solenoid, okay? So imagine this. Here is this, and here's your magnet. Imagine this is a magnet. And here's the solenoid. And the magnetic field is coming out like that, okay? So this is the north end of the magnet. So imagine that you have things, the magnetic field is coming out of this, here's the solenoid. So in the plane of the solenoid, what are you seeing? If you're the solenoid, and here's the north end of the magnet, what are you seeing in the plane of this? Are you seeing X's? Or are you seeing O's?
If it's going in, it's X.
Right? I guess it depends on
It's
which
coming
way.
from-
Yeah, which way am I? Where's
If
it
it's
going?
going in,
You're on the other end of the magnet.
In this one? It's X. I thought it was putting.
Shush! Here's the north end of the magnet.
Okay.
Which direction do the magnetic field lines go?
Out of it.
Out. Okay? So if you're within the plane of the solenoid,
I was thinking about the
okay, here's the north end of the magnet. Here's the solenoid. If you're the solenoid, what are you going to see? X's or O's? X's. Okay?
It's going through the
It's in the plane of
Yeah, it's
it.
going in.
Like, imagine a
Yes.
paper.
So these things are going in that direction. They're pointing into it.
Oh, we're looking at it? I'm sorry.
No, you are like your face is the
Well, I'm
solenoid.
not-
This is the
He's
magnet
over
coming
there, so
at
it looks like
you.
you're.
So that was
So it's going into you.
Imagine it's the shower. Okay? Here's the shower head. This is your face. What are you going to experience?
Wet.
good joke,
Okay,
Kate.
you experience X's.
Why?
Okay.
How was the X?
Hey, why?
Well, I'd understand if I was looking at.
Gavin,
I'm
I'm
sorry.
looking the other way.
here's my pencil. This is a magnetic field line. Here's the North Pole. It's going this way. It's going in that direction.
And we're looking at. So that's an X. That's an X.
Yes! It's an X!
Okay.
Oh,
I got it.
I'm
You were explaining like we were looking like behind it.
No! You're looking at it!
Okay,
You're
yeah,
here!
X for sure. It's an X for sure.
For her, I have a separate question. I don't get mad at me, right?
Oh,
I would never do that.
Okay, so yesterday, right, we had loop up here, loop down here. He
They're
was
two
going,
completely different things. Just,
how?
hold
It's
on.
the same part.
Let me get done with this.
And then you'll explain to me?
Yes.
Thank you.
Okay. So, the North Pole magnet determines the direction of the induced current when the magnet is being pulled out. So, I'm going to pull this out.
Yeah.
What is Mother Nature going to experience? Less X's, more X's, more
Less.
O's, less O's.
Less X's.
Less X's.
We need
More. Fewer X's. So if you're decreasing X's, what are you going to make?
X's.
More X's. So in this plane, I need to make more X's. So what do I have to do?
Up.
Wrap my hand this way so the current's going to be going.
Oh, clockwise.
That was,
Yes.
Wait, what? We're lost.
I need a picture.
Because it's X, so it's going.
Okay. Here's the plane, here's the
I don't see
Yay! Did you get it right? And that's how it's matched. And we needed to just try to go here. Then it's gonna go.
Oh wait,
are
are we doing from wherever it's very bottom?
Is
Are
this
we
what
on
you're
the
like, essentially?
What floor are we on?
We need
I don't-
current
what-
going the other way.
where are we going?
The only way that it makes sense to me is we are the solenoid and it's coming into us, and that's why it's happening. But then if we need it to be more axis, we go counterclockwise.
What did you just said call
Kind
it?
of like-
I'm gonna.
Down.
fucking dumb.
Wait, Michael, it's clockwise or counterclockwise? Down. It's gotta go down.
What did you put?
It's counterclockwise.
For this?
No, he just said it's clockwise.
No, on this one.
What do you
All
mean
your
clockwise?
forces are intense.
What do you mean by clockwise?
This one, what did you get?
Hey, what is the word clockwise?
Nick, you went over in class.
I get away.
Sure.
I don't know this time.
Okay,
I give up.
solenoid, north end of the magnet. Okay, got this, north end of the magnet.
Yeah.
The field lines are coming out from here and into here.
And we're defining that as
Okay.
X.
Huh?
From our perspective, that's an X. Just so we're clear.
It's coming
You're
into me.
looking at this.
I'll slap him for you.
The magnetic field lines are coming out. They are pointing into this.
Okay, yes, yes.
That's the axis.
No, because if you look from a different perspective, it's an O.
What's the flip of the coin?
We're trying to make sure we're on the same page.
What's
right?
the
Make it
It's overcomplicated. Just look at the face.
You are looking this way. You're
Yeah,
looking into the tube. You're not looking this way. You're looking into the tube.
Yeah, you're looking into
So if
it.
they're here,
Into the tube.
the field lines are pointing in. You're going to have X's.
Yes.
Okay? Now, I'm going to pull that out. What's going to happen in this plane?
Less X's.
You're going to have less X's.
So we make
I
So
understand it
what
now.
are you going to do?
More X's. Current.
So I need to make X's inside this plane.
Okay.
So I need to wrap my hand like this to induce a current that goes around like that to make X's. Big Mike, so help me God if you ask.
So,
I got down.
now when I was thinking about this last time, I was stuck on this idea of like,
Bro,
down and up.
It's gotta put down instead of clockwise or counterclockwise.
Oh, you're talking about like north and south?
Oh, east. So on the last page,
Hey, I went while we're
this
at
part,
I need a picture.
should it be counterclockwise?
Oh.
What? You need more X's.
For which question?
For the last question,
We didn't need that prelude to answer this question.
Yes,
It should be counterclockwise.
Good work.
yes.
See?
My bad, I should have explained that earlier.
Well, no, I was just stuck on the whole down.
Oh my
up
God.
idea.
I was explaining this one? Yeah.
Okay, now to your question, Mr. Jones. So, because a lot of you had this answer wrong, so let's talk about this. So, you've got a loop, okay? Go with this. And I'm going to drop, there's two situations. Do you want a completely separate loop? Is that what you want to talk about? Like if there's a loop up above?
Yeah, a loop up above.
Okay.
Not an anytime.
So let's say there's a loop up above like this, right?
Yeah.
I close this switch,
Yeah.
and let's assume that the current in the lower loop is going around in a clockwise direction.
Gotcha.
So if that's the case, as soon as I close that loop, immediately there's going to be a surge in current.
Yeah.
So that's going to go like this.
It's that the
That
magnetic
means
field is
this
the one that's
up
like
here
made in these
is going to experience a magnetic field that's going to be coming up through it.
Wait.
Yeah, that's
Oh my
Oh,
god.
sorry.
Gavin?
So the
I was
magnetic
doing
field
last
is generated
Okay, but
the
Bert.
change
From,
in the
Hold on.
magnetic field. Right.
Okay.
shut up!
So we're cool that the current's going this way.
Yeah, so it's coming out.
Michael.
So if just don't worry about the top wire.
Okay.
Forget the top wires though.
I got you.
So I put my hand this way. My thumb is going this way. Then around this lower wire is going up and around and coming around like this,
Yes.
right?
Yes.
Now, so as soon as I put a second loop up above it,
Which one is?
okay? So that loop up there,
No, I told him so.
if I put my thumb in this direction, so that loop up there is from this top perspective, okay? If you're looking down, it really doesn't make any difference how you view it. But if I do this, okay, if all I see is this top loop, let's say I don't know anything about the bottom loop. So if I'm looking at this top loop, I'm seeing magnetic field lines coming out of the top of this. So from this perspective, I'm going to see dots. Okay? I'm going to see dots. Mother Nature is going to do what? To counteract the dots.
Make X.
Mother Nature is going to make X's. So in the top loop, Mother Nature is going to put X's.
Oh.
So then the current's going to be going in this direction to produce X's to counteract the O's that are coming from the bottom loop.
So the current's going the other way.
Yes.
It's a question on the test.
That's all.
Problem.
Very, very, very high probability.
Okay.
Can we do the other one
Okay.
where it's like?
Is there anything?
Okay,
I
I think we should just like.
Okay. But now, after it's been going for a while, what's going to happen to the current in the top loop?
That's
None.
good. That's gonna be none.
It's going to go to zero. Does
There's
it
no
still
change.
have a flux?
Yeah.
Yes.
Yes, but the flux
It's
Does it
constant.
change?
is changing.
Oh.
So now there's no current.
There's always flux, but there's no change in flux.
There's always flux, it's just whether or not the flux changes. So,
It's whenever.
now,
That's whenever it makes voltage.
shut off
That's when it makes
the
current.
switch. I open up the switch.
Changing voltage.
Oh.
That's why I
Then,
make flux.
if I shut off the switch and the current's going this way, then that magnetic field is going to decrease. So if you're up here, you're going to have less X's.
No, less O's.
We need more X's.
It's less O's. It's
It's
O's.
less O's.
Oh,
That's
sorry,
right, because the
sorry.
O's come in. So you have
Okay.
less O's, so you're going to make
More O's.
more O's.
And the current's gonna go the same way for a second.
Yes, current's going. So what's going to happen is to alternate. The current's going to go back and forth, otherwise known as AC current.
AC.
So whether you open or close the circuit determines the direction of the current in the upper wire.
Okay.
Okay?
Can we do like theoretical questions?
Do what?
Or like some like, I don't know, some like transition or something.
Well, hold on. Popcorn.
For like question 10, like is the like it, okay, I don't know how to explain, but like is the current moving towards the magnet,
Yeah.
or is like the magnet like on the
The
right?
the magnet is stationary and you're moving towards the magnet.
Okay, I was just making sure.
Yeah.
Are we supposed to use the data we got? Or are we supposed to use the data we got?
It literally says. Use this.
Okay. If you want to hold on, what?
Number 9, are we supposed to use the force from the data we got? Or are we
Yes.
supposed to-
Yes.
Chat, making up his own equation.
Make up an equation.
I got one last question.
You sure? Scout's honor?
Scout's honor. Last question of the day. Maybe not of the day, but for this assignment.
What?
Okay, so on C on the last page, you already went over it, but you talked about how the magnetic flux wasn't changing. How does that relate to force?
It's like constant velocity, bro.
If
It's like the
there's
same
no
thing.
It's amazing.
change in the magnetic field, if nothing's changing, then there's no current.
No force.
If there's no current, there's no force.
That's all I need. Adam, shut up. That's all I need.
I'm thinking about it.
Does that make sense?
Velocity doesn't change.
So the force is 0.15.
What?
That's
We
why
got different force.
Yeah.
That's why. Yeah, you got it.
I don't know.
It's our
What is that?
review.
Oh,
Oh my god, our review. Yay! We're the best.
Is this gonna? Is there anything we can say?
Do you think you get mad if I'm playing rocket league right?
Well, I guess, well, when I said, remember it's the thing with the X.
I'm Mr. Bear.
Yeah, that's good. I mean, tell me if it's not. No, like legit. Okay. I mean, you could just explain that there was access to
Something's
magnet.
moving, then it might change the
I
magnetic.
think I don't understand it enough
The
to
loop,
explain it
so
to them.
yeah, the loop,
Okay,
the loop,
just
so
leave it
basically
then.
why it
And I don't wanna
only
be
does it
wrong
when
if
you
I keep
automatically
explaining.
change it,
Yeah.
and when you turn it off, is because that
On this
voltage is
one,
changing.
is it,
That EMF
like,
is
is
changing.
this wrong?
Yeah,
And that's what
well, yeah,
induces
it's supposed to, I
the
didn't
current
count it
up
off
there
because you
it's
did
changing.
say
But
yes,
it's
it
not changing,
was,
it doesn't
but
make
technically
sense.
the force is to the
Think
inside.
about it like, what I think about it is like, it's like velocity.
Hey,
Velocity
Bert,
isn't changing, there's no force.
But we're
Or
gonna do the
can't.
Willie
What?
and
Alyssa wanted me to record this.
Okay.
So will you upload it?
or we're gonna be stupid.
Okay, so
More like it.
this will give you some idea of your thought process. So try these two questions on here. And let me see what you get.
A permanent? What's the difference?
You wouldn't say work with others.
He's wrong, okay.
We'll figure it out. Yeah, so you're looking at this plane right here.
Okay, okay, hold on, let me reassess. Reassess. Just making sure. Oh, wait, yeah, right, yeah.
What? Stop. Shut up. No, because if you're looking
Hi,
from top
Shannon.
down, they're coming out. Oh.
Hi, Shannon.
Yeah, if you're looking top down,
So you
as,
got
it's, no, as it's falling down, if you're looking, it's falling.
What?
Did you see the decisions to
Wait, Mr. Burke,
Top
can
down,
we
right?
keep these?
The 50%?
Oh, yeah, it comes
Yeah.
down, it's coming.
Did you like
coming
our
out,
item to escape?
right? Out, O's.
Jack, you wanna keep yours?
The O's, like that's O's, so you're trying to make more exits, but then you're trying to. Yeah, but as it's falling, or, yeah, more. No, but it makes more exits after it falls. When did you take this? Okay, as it's falling, it's not all the way falling, right?
Yeah, so you're looking at as it approaches it, and then after it passes through.
After it passes through. So you make more exits. Oh, the, hold on, wait, I was wrong. Wait.
Yeah, so tomorrow, before the test, I swear we're gonna do this, we're gonna have to do like hand exercises to make sure you don't like fold your muscles during the test.
So we don't get carpal tunnel.
You said yes.
Very.
Whoa, you
Very.
changed your mind.
It's just
go
so we don't
and see if
get.
he had his hand cut
It's
off.
just so we don't get carpal tunnel from like
So you
doing
said-
all that.
So you're saying you can get one?
If you have your hand cut
You
off.
know, it's like.
What if I get someone
What's
else?
that?
Like, what if I go to the
No,
wall?
it's-
I get someone else's
I don't know
hand.
if
So
they're
they say,
right.
hey, spare a hand.
Hey, let me, give me a hand.
Alex.
Give me a hand.
What?
Okay, so in the name of time, let's chit chat about
It's
this.
so we don't get carpal tunnel.
Yeah.
So you have, what's the first thing you have to know to answer this question?
Which way are the lines?
Which way, what?
The lines are
The
going.
field
Which
lines
way the
go.
lines go? If you don't know which direction the lines are going, you are dead in the water right from the beginning.
I'm pretty sure.
Okay? So, which direction are the lines going?
North to south.
So they're emanating here, okay?
Yeah.
And they're coming in here.
Yes.
Okay? Go with this. So here's the ring, okay? And this is the south end of the magnet. The north end of the magnet is up here. South end. So you're coming around like this and coming in like this. So as it's approaching, in the plane of this circle, the field lines are going up. So in the plane of the circle, are you seeing dots or are you seeing X's?
Circle.
X.
Dots.
You're seeing dots.
Outies.
Oh, I'm seeing dots. It's going away from
I'm seeing ghosts.
Okay, that.
Can we do
I'm
outies
going
and
insane,
nineties?
actually.
Yeah.
Are you seeing outies or innies?
Outies.
You're seeing outies.
If you're
Sure.
looking towards the magnet, you're seeing dots.
Yes.
I'm gonna see
Point
Jewish
of
word
view of
after
the magnet.
So
Bro,
we're
what
looking at the top of the ring. The top of the ring,
You know what I mean?
the
Shaq?
magnetic lines are
So I'm
going
seeing
up
dots.
this way.
Yes.
You know what
Okay?
happened to Jewish
So
word?
from the top, from this perspective,
Yeah.
the field lines are coming out,
Yeah, we got that.
Got
which are
you.
dots,
That's
outies, whatever you want to think about it.
Yeah.
Now, as it approaches, what's going to happen to the intensity of the dots?
Increase.
You're going to get more and more dots. You're going to get more and more dots. So what are you going to make?
X's.
X's. So in the plane of this field, you need to make X's.
Yes.
Here, you need to make X's. So what are you going to do? How are you going to do that? Clockwise, counterclockwise.
Hold on. Speed up.
I need to make X's in here.
It's a clockwise field.
Clockwise.
So this needs to go in. So my thumb is going to
Oh, wait, I
point
see.
in that direction.
Counterclockwise.
So it's going to start off
Oh
as
my god, my stupid.
clockwise.
My stupid.
Okay? It's going to start off as clockwise. Because I need to make X's inside of here. Shaq? Now, after it passes through,
I don't get it.
the north end is now going away from it.
Yes.
It's falling completely through it. This is important. It's all the way through it at this point. So, from the ring's perspective, this is the north end. Now, here's what's different. This is now the north end, right?
Yes.
Okay. So now the field lines are still coming up.
Yes.
But you're going away from it.
Oh, so less.
So you're seeing less
Oh.
O's, so you need to make
X's.
more O's.
Laura.
My fault.
So therefore, the current's going to go in the
Counterclockwise.
counterclockwise direction. So the correct answer is A.
It'll be clockwise and then counterclockwise.
Huh?
They're literally.
But this now, this answer plays out. This runs out.
I know what it means, bro. I know what it means.
Okay. On B. So here's your magnet. Okay, literally, it would be a situation like this. Here's your magnet, and you're going to move this thing through it like this. Okay? So here's your permanent magnet. There's your magnetic field. X's, so the magnetic field is doing what? It's going into the page, right? Here's the glider. Here's the loop. Loop comes in. Inside the loop, what is the inside of the loop experiencing?
X's.
We're seeing
More X's. The inside of the loop is seeing more X's. So what is Mother Nature going to do?
Great O's.
Make O's. Oh! So the current then is going to go counterclockwise because I need to make O's within this. Ow! So we got the O part. Good with this.
See.
Now, to figure out the direction of the force, now you have to use the right hand rule a second time. So here's that flat edge. We just said the current was going up. But the magnetic field is going in. Which direction do your fingers point? To the left. So the force is going to make it
Slow down.
slow down. So this is why when I push that cart into it, it slows down. A magnetic field,
Very early smart.
the magnetic field will never make it speed up. If you do this and you get that force pushing in the same direction that the car's going, you have done something horribly wrong. Okay.
Berg, how do I get as smart as you, Berg?
Make lots of mistakes.
Hey, that's true.
I can do that. I'm already good at
Me too.
it. After this test, I will be so smart.
Literally.
Yeah, you're looking into the plane of that.
I always look into it.
Yeah.
Bro, this is
Hey,
Can
how
you
much-
explain to me the question? Can you explain to me the question?
How much do you think meta glasses?
Okay, so it's specifies the front edge. So when the front edge, this part crosses in, you're gonna get a lot of X's. So you want more O's specifically on the front edge. It's the front edge. You want O's on the front edge. So it's now the front edge going up.
Make lots of mistakes.
I'll tell you again.
Because the only way the current's going this way. The way it
I heard that. Yo, why was
And then the magnet field is always going in the page. And then also magnet field never makes it speed up.
Yeah, Michael. It's not dig.
So it's actually dig.
Is this true, Kayla?
No dig.
No dig, Michael.
Where can I get more practice problems?
If you just Google like AP free response questions, you just have to kind of sort through them and find it. But then if you know like what year it is, you'll also find the answer keys to them. Hey,
What happened again is should we turn it 4 and 8? Can we keep it at 4? Yes, you did. You said keep it to the base.
Didn't Ethan fail that quiz?
okay.
Are you the only one?
Shush. Okay, so let's talk about that first problem, because this incorporates a whole bunch of things, which is the code for Brokamp license question a lot. So, you have two things going on. You have radioactive source, which is kicking out something. We don't know what, you just know it has a positive charge. This is important.
Is this question 5?
The one, yeah, 2005.
Okay.
Okay?
11 right there.
So, up on the top, you have a negative electric field. It's this one. This is radioactive source. And has a positively charged particle coming through here. And you have a positive down here. And you have dots that make up the magnetic field, right? So, a couple of things that are important. You get a problem like this, the first thing that you do, Nathan Nelson, is you read the entire thing.
Oh.
Okay? Do not jump down and start trying to answer the question.
My bad.
You look at the entirety of the problem. I mean, you read everything, because if you read the entire problem, that will allow you to see the big picture of like, okay, where are we going to end up? So, the magnitude of the magnetic field can be adjusted so that the particles of particular speed pass through the selector in a straight line. In a straight line. In a straight line. So let's talk about this. Forget about the magnetic field. You shoot a positively charged particle into that electric field. What's it going to do? It's going to go up. Why?
Because that's negative.
So it's going to go up for two reasons. It's going to be attracted to the negative, and it's going to be repulsed by the positive. So the electric field strength is going to push it up.
Yes.
So what's the only way we can avoid it going up? If there has to be a force going downward. Now let's see if that makes sense. Okay? So you have dots, which means the magnetic field is doing what? Coming out. So if I use the right hand rule and I point my thumb this way, the magnetic field is going which way? Down. Out. So the force of the magnetic field is pushing it down. So the electric field is trying to drive it up. The magnetic field is trying to drive it down. So it's the only way it can move in a straight line.
If they're equal.
The force is equal.
If they're equal.
Okay.
So the force of the electric field has to equal the force from the magnetic field. So, on part 1, it says, derive the equation, velocity equals EB1 for the speed v of the particle that must move in a straight line. All they're showing is that, hey, how can you get to that point? So what are the two forces?
Force
The force
applied.
from the magnetic field and the force from the...
Electric.
How are you going to find the force from the magnetic field?
We'll just find it.
Are you going to believe?
Yes.
Believe?
No.
Don't believe.
You do the
Oh, it's a
other
particle. We
one.
gotta use Q.
Wait.
QVB. Stop saying.
How about a little
QVB.
QVB?
Kuvu.
Are we facting here?
Kuvu.
No effect.
Now,
Effect's long gone.
no, it's not.
It's coming back.
Oh, the question.
It's coming back.
Bro.
Bro, it's back.
What was that?
Are we perfect?
Dude, okay.
He's ready for quantum physics.
Cancel. He's just bogging.
Cancel the Q.
Cancel the Q.
Oh, the Q is going to cancel out.
You gotta be B.
B equals
E over B.
V-
Yeah.
E over
Oh, look, it's one.
B. But this is B1.
Wait, that's all that question's asking?
That's all you have to do.
Oh, I was confused.
Wait, that was
That's all you
great.
have to do.
Wait, so it gave you the answer?
So we
But
just
it's,
the
the,
answer.
the point came from deriving it.
You had to like show how you got that.
Okay.
Bro.
That's
So
lucky
if
ball.
they tell you what you end up with, you have to show how you end up there.
Girl, I mean,
That's not proof.
no,
Oh, hell no.
no, leave that.
Now,
Now.
so on the next part, some particles are emitted from the source with speeds greater than E over B1. So, which of the following describes the initial path of these particles immediately after entering region 1?
I think B.
Oh.
So, here's the story.
You're on the wrong side.
Where are you at?
Are you serious?
Oh wait, I'm on.
Me?
No.
No, I was on the wrong side.
Oh, right.
What would you get?
So, what's the only thing that the velocity is going to alter?
Magnetic.
What?
The force from the magnetic field.
Oh, yeah.
Down.
Yes, this is the only one that's dependent upon velocity. So if the velocity is bigger, okay,
Oh, FB is bigger.
FB is bigger, and what's the direction created by the magnetic force? Downward.
Oh.
So if it's going too fast, the particles are going to go which way?
Down.
Downward. If they're too slow,
Up.
they're going to go up.
Yeah.
Does it matter if the particles, some of the particles have a charge of +2?
Q's cancel.
No, because Q's canceled.
Because the Q's cancel out.
Gone.
So whether they're +1, +2 doesn't matter.
Yay.
Okay? The only thing that matters is the ratio of the electric field to the magnetic field.
They're weird.
Okay? Cool with that? All right.
Once you understand it, it's like.
So, now, over on the backside, yes, there is a backside. Okay?
Region 2.
So, constant magnetic field is directed into the page in region 2 to the right. Suppose a particle leaves your radar travels through the region in a straight line. So this is going to be important. They have the magic velocity to travel through that. Okay? And you can, so here's the beauty of this in terms of the physical setup. These particles are probably traveling 10 to the 5th, 10 to the 6th meters per second. And you can't see them. Okay? I can't. But what I can measure is I can measure the voltage, I can measure the electric field. I can measure the strength of the magnetic field. So this is a situation I don't have to measure the velocity in the traditional sense. I just have to know the ratio of the electric field to the magnetic field. Okay? So I could find the velocity without measuring the velocity. Does that make sense?